Okay, so welcome back. Uh, we will now try to answer the questions that already have been either it has been posted in the WhatsApp group or in the chat box. And after that, if time permits, we'll take few more questions also. Okay, so let me start with the questions in the chat box. So the first question is from Dr. Tamal Sarkar from North Bengal University, that how to check our new mobile phones is NavIC enabled. Okay, so what we will do in the next week, we will show you how to download different apps what are already present in the Google Play Store, and use that apps. So whenever you will use those particular apps, you will find that it will show you in color coding with the flag of particular country, that whether it is the GPS signal, whether it is GLONASS signal, or whether it is Galileo signal, like that. And if your mobile is NavIC enabled, so you can see the Indian flag and the NavIC signals. It is being tracked. What are the signal strength? What are the satellite number, etc. You can see. But basically, as my information goes, or maybe partly right, because in the market, it's a very fast changing market. So there are a few phones which are from Xiaomi and also from Realme. Only those phones are till now, those are NavIC enabled. If you have any more information, anybody here, he or she can share, no problem. Which are NavIC enabled. So that is the first check. Not many manufacturers are coming up with NavIC phones, though ISRO is working hard with many of the manufacturers. What I have read or learned from many platforms, that ISRO is working hard, like Qualcomm or other manufacturers, so that for the Indian segment, you can very well understand it's a regional system. So in Europe, that particular chip will not be sold because they have to pay extra money for that extra facility. So from the business point of view, it's difficult to get all the phones having NavIC enabled phones. But you can check if your phone is a Xiaomi one and or a Realme one. You can check the data sheet, and secondly, you can we will show you how to download and use the apps using which you can see and you can record data. So using that one, it is possible for you. Next, from Dr. Orpita Guho, can you share links on online GNSS data by OSPOS, OPAS, or NRCan? Yes, definitely. Number one, I will share the PPT, barring one or two because of IP reasons. With you, everything is given there. If you go to their website, you can very well understand how to upload, how to collect your data. It should be a dual frequency receiver. Using dual frequency receiver, what is the minimum time requirement? You have to collect your data and then upload your data into either OSPOS, OPAS, or NRCan service. All of them has got some restrictions. Some of them can only process GPS data. Some of them can process GPS plus GLONASS data, but still now not GPS, GLONASS, and Galileo data. But you can do so that you can find out the exact location of your receiver. That means your antenna, or the reference location. But there are certain rather recommendations also. The recommendations, all, it's not like that once you are doing it and forgetting. It's not like that. You have to keep it doing every month, like that, and check if there is any change in your reference location, and keep on updating into your software the reference location. And I think the ISO, I have worked with that document, that they're trying to come up with some solutions, or a document, that how to establish a reference station. So what are the recommendation? So any core station that has to follow that particular recommendation to get ISO certification. So I think just during the pandemic it has started. It will take some more time. But obviously, from the presentation, you can you can directly find the link and use it. Next question is from Manos Chakraborty. Sir, as you have discussed earlier, for finding XYZT, we need only 4 satellites, but there are a huge number of satellites in the region. So my question is, by which parameter we choose the 4 right satellites among them? Manoj, the answer is we do not choose four satellites. Whatever possible, as per the capability of my hardware software, we take data from or signal from all satellites. That makes our life simpler. That means we get very good, we get very good DOP. That means DOP is a measure of satellite geometry. The scattered the satellite geometry on the sky, the better. So instead of using 4, if we try to use all of them. But we published a paper. There we have seen that from the DOP point of view, if you go beyond 20 or 21 satellites, there are not much improvement. Up to 20 satellites, there are continuous improvement in the DOP, that means satellite geometry factor. But that saturates when you reach in 20 to 21 satellites. After that, it will not improve. But there are certain other factors that I rather missed or just could not bring up the topic. Thank you for the question. That whenever we are using 2 or more systems, for example, GPS and GLONASS, for example, GPS or Galileo, for example, GPS, GLONASS, Galileo, there are certain things. What is written in my slide that it's called the inter-system bias. So what is inter-system bias? Every country has developed their own navigation system. For them, the reference geoid, what they are following, for example, in case of GPS, they follow the WGS84. I think the person who would be talking about GIS and GNSS would be more emphasizing on that one. So they follow WGS84 datum. That means how the Earth is modeled. It's a model. How the Earth is modeled. GIS 84 model, yeah, WGS 84 model, and their own timing reference. If you go to, in case of uh, GLONASS, GLONASS once again uses a different model, what is called the PZ90. Okay, Z is Emily, that means coordinate, PZ90. So, and use their own system. So obviously, whenever we are using the GPS and GLONASS together, the references, their reference frame and their reference time, they are different. So to merge them together, you have to do some extra mathematics, that how the GPS GLONASS coordinates can be converted into GPS coordinates and fuse them together. So the more systems you work on, so this type of challenges becomes more difficult, more challenging. But simply many of the geodetic receivers, that means high grade receivers, they takes care, so because they have got some own models. So I'm getting, this is the GLONASS result and this is the GPS result. Using certain model, they fuse them together and then gives us the solution. So they are taken care of very good way. So that is the answer, that many of the geodetic receivers, all the geodetic receivers and current small receivers, even now they have got say 200 plus channels, right? So 200 plus channels, so they will use all the satellite signals that is available, be it GPS, be it GLONASS or Galileo, whatsoever may be the case. But they need the processing capability to fuse them together to give you the best result. Otherwise, for what happens if you do not know, for example, how to cook 2 different things, how to cook a very bitter thing and a sweet thing. So until and unless you do not know what particular ingredient in your cooking you would use, so that they fuse and give you the best taste. Otherwise, it will neither be bitter, neither would be sweet. So it will lose all of its attributes. So that is a challenge. It's still now it's an open challenge. Many people are working on this one. For already existing models are there. It is being continuously improved, and more people are can work on this one because so many systems. And the challenge is more for us because the original developers, the Russians, the Europeans, or the Americans, they do not have the facility of getting so many satellite signals together. So the challenge, basically, we have the advantage. Basically, we have to use the advantage. We have to work hard to use the advantage. I think I have answered your question. Okay. Then the question from Milan is how to track any object using satellite signal. Is it possible? Yes, it is possible. Very simple thing. Suppose you have got a bus, right? How it is done nowadays. You have got a bus. On the windscreen of the bus, you put a very thin type of GPS antenna, and from that, take the data and put it into a very small receiver, and the whole system runs on the car or bus power. So, what along with it, there should be a data transmission facility. Okay, maybe Wi-Fi already installed into the bus, or maybe mobile dongle. So using that one, the data it is collecting, somebody definitely will talk about the GPS data form, GNSS data format. What type of data we get from the GNSS modules or the GNSS receivers? I will talk. If not, I will talk about that. So from that data, you can find out your latitude, longitude, and using that communication module, you can transmit it to some other place. For example, to other module. So that is very basic of if you go to say Amazon and search for GPS trackers, you will get very low cost, some 2000 rupees, 3000 rupees GNSS trackers, which are already installed, which are very commonly available in the market. Our company is working on developing such a NavIC based device, and we are nearly reached is the prototype design, and it will be an interactive one that on the map you can see where your vehicle is, and many solutions are there. I think if you have if you have seen while you are moving in the highway, you must have seen on the backside of the trucks, a sticker is there called Wheelseye. Wheelseye is a company. They give service for truck vehicle tracking. Earlier it was a problem, so there is no tracking. Many times the trucks were getting snatched, the driver was killed, and the whole consignment that was being robbed away. But by doing this type of problem, the owner or the company can keep track of where my truck is and where it is moving, whether it is moving in the speed in which it is moving, overspeeding or lower speeding. This type of applications are available. And tracker, you can develop it by yourself by simply integrating with a small module, a communication module, and a central data processing unit. That is very simple. You can do that. Okay, now let me take the questions from WhatsApp. A few questions came there already. Okay, just a moment. Okay, Orpon has asked that does the Doppler shift of the carrier signal causes any type of errors in the positioning? Obviously, if it is not taken care of, it will cause a problem. But beforehand, we know that there is a Doppler. So in our processing software or the processing hardware, we take care of the problem. The Doppler is there, and from the Doppler, we have to take care of the Doppler. I'm not telling reducing or stopping it. You have to take care of the Doppler. Next, and his another question, and can the Doppler shift be used for measuring speed and heading of the receiver if it is mounted on a moving platform? Already I told that we do not use Doppler shift for tracking a vehicle because it will be very complex and costly. Instead, simply every second it is giving data. It is giving you latitude, longitude, and altitude, right? So at this moment, at point time t1 here, time t2 here, time t3 here, time t4 here. So we can have a trajectory of the vehicle. We do not need to Doppler shift. But Doppler shift can be used in case of satellite application. Doppler shift is already what you yourself told, the Doppler shift is a measure of the velocity of the rather satellite itself with respect to the receiver. And obviously, when the platform is moving, the receiver is on a moving platform, so the Doppler will change. The relative velocity in a static condition and moving condition, that will change. You can theoretically you can measure the Doppler shift, the earlier Doppler shift and the new Doppler shift, to measure the velocity of that vehicle. But that is cumbersome and costly. Instead, simply I've got location at T1 it was here, at T2 it was here. In time differs between T2 minus T1, how much it has moved. So that is the velocity. So that way it works. But Doppler shift in many cases, other than GNSS, It is used to measure the exactly monitor the velocity of the satellite itself. Yes. Any more question? If not, I have asked two questions. I wish to have the answers. Number one, if all the satellites are moving, number one, why the satellite should move if we put into orbit? Why they cannot remain static? Any student? Any student, you can uh, answer here on the chat box, or you can open your microphone and answer the question. Then, rather, any senior person, he or she can tell.
Sir, I think that as your PPT presentation,
No, no,
the
it's not related to my PPT. My question is, if I want to put something is obviously artificial satellite out of the surface of the Earth, why it should move? Why it cannot remain fixed? And what is the basic of what you have learned during your BTech or BE classes in satellite communication? Otherwise, it will fall on the surface of the Earth. The inward force and the inward force should be taken care of by outward force. From where the outward force will come if it keeps on moving. So due to the movement, the outward force will come, which will counterbalance the inward force, and it will remain in its orbit. My number two question was, if this is true, then how come a geostationary orbit remains fixed with respect to our location? Anybody, just try. It's a Q&A session. You can give wrong answers. Nobody will frown on you. Okay, anybody from the seniors try to help the juniors? Okay, if not, actually, it's not static. It moves, a geostationary satellite moves in the same velocity with that of the Earth in a particular height. That's why its relative velocity is zero. It is actually moving in the same velocity with that of the particular point or the Earth. That's why it remains. It appears to be within quote. It yeah, yes, same velocity with Dr. Kamble and Tamal Babu has answered the question. But my question, definitely I expected some answers from the students, young students who are now PG students. Anyway, you have got seniors who will help you regarding this and also during the offline. And third, I have given you a very short problem that if you convert 1 nanosecond into a distance, how much would be the distance? Manos has given me the answer. So it's very simple. 1 nanosecond, 10 to the power minus 9. So multiply it with the velocity of light. That means 3 into 10 to the power 10 into 10 to the power minus 9. So it will be 30 centimeter. So if your mismatch is 1 nanosecond, your error would be 30 centimeter. And we are talking about millimeter level accuracy. So that's the point. So now it's still open. If you have any question, comment, suggestion, before I forget, everybody, please join tomorrow at 5:25 because tomorrow the speaker would be Dr. Ivan Petrovsky, and he will be talking from Japan. And Japan lags behind 2.5 hours. So it's his courtesy that he agreed. If we follow the 7 p.m., so he has to start at 9:30 p.m. in the evening. So he requested, and we agreed that we will be starting at 5:30, and it will later end at 8 o'clock. So bear it in your mind and please join at 5:25 tomorrow. Okay, so if there is any more questions, we have got 1 or 2 minutes left. Or if the question requires, I can remain here for a few more minutes, no problem. And another reminder, if you have not submitted your Google form response for finding us what type of meal we need to arrange, kindly please fill it up and so that we can beforehand we have got some information that how we would arrange our meals.
sir, if you told us at the classroom how code-based measurement is working, then it is very helpful for us.
Okay, so I think tomorrow Ivan will be covering that one. So I just touched upon all the aspects of GNSS. So it is obviously for the first time it is quite I'd rather say a bit difficult to understand at the beginning. I think Ivan would be covering different types of error sources, GPS positioning method, and how these errors are taken care of. So, if
Thank you.
not, we will ask him or any other experts, and ultimately we are there to answer your question. Okay, so thank you very much. If there is no more question, still, if you have any more question, the WhatsApp group is completely open. Whenever you like, you can put your comment, suggestion, and your questions there. We will take up or place before the experts for their comments and answers. So goodbye for now. Uh, have a nice dinner. Good night. We will end the
Thank you,
call.
sir.
Okay, thank you very much.